Science is full of conspiracy theories. The moon landings were faked, and climate change is a hoax. But how many of them are likely to be true? I spoke to David Robert Grimes from Oxford University, who has given conspiracy theorists the benefit of the doubt, and built a mathematical model to test whether, if these conspiracies were real, they would still be a secret.
I found that conspiracies of the magnitude required for the entire scientific community to be involved would collapse really, really quickly. Even if every actor there had, the most malignant intentions at heart, you wouldn't be able to sustain most of these conspiracies for much longer than 3 years at the absolute maximum.
So you said for the whole scientific community to be involved, surely conspiracies don't need everybody's involvement.
In general, I think that's correct. However, with a scientific conspiracy, let's say climate change for a simple example, you couldn't just have one, nebulous group or small grouping faking data or making up this kind of consensus, because science by its very nature tests other findings. That's how we uncover academic fraud, for example. Another group will very quickly point out that's not the case. When they redo the experiments, nothing is done in science on authority. It's done on, experimental evidence. So to get a scientific conspiracy happening, you would need everyone in a particular field to conspire.
Someone would blow the whistle.
Blow the whistle or just be really inept. I mean, an email sent to the wrong person or a clumsy exchange, this stuff would come out very quickly.
I think we should emphasise this is extremely rare. Scientists are, in general, trying to do legitimate research and not deceive anybody. But you needed some conspiracies, some genuine conspiracies, to put your models together, didn't you?
I did indeed. And the thing is, I couldn't actually find any classic examples from science because, as you've said there, it just doesn't seem to happen. I think there's a popular misconception that scientists all get together and agree about everything. Anyone who works in science knows that trying to get all scientists to agree on something is kind of like herding cats. To train my model, I had to look at conspiracies that happened outside of science. So I looked at the Edward Snowden NSA PRISM revelations. We had numbers on that. We had time frames. We had an upper ceiling on the amount of people that could have been involved.
How did you go about answering that question using this data on other types of conspiracies outside of science?
So I started looking at, okay, let's play devil's advocate for a few minutes, and let's look at what you would need to sustain a conspiracy. And let's see if we can estimate this from real parameters, which is what we took from the Snowden data or whatever. Taking that number out for the failure rate per person per year, you can then use Poisson statistics, which are used for a lot of things. They're used for everything from working at traffic light intervals to radiation damage in phototherapy. And the reason they're used is they're basically the statistics of discrete events. So if you have an average rate that something happens, let's say you own a shop and 4 people come in an hour and that's your average rate, Poisson statistics will help you calculate in some time interval whether you expect what the probability of 10 people coming into that shop is, or 2 people, or 7. So they will help you count discrete events and give you a probability that a number of events will happen at a given time.
Which is really useful for this conspiracy theory data.
Absolutely, because all I need is one event. So even if the odds are very, very low, I want to say, what's the time frame that one event is very, very likely to happen? I think the probability per person per year of a leak was 4 in a million, so 1 in 250,000, which is a pretty low chance per person. But when you start adding people up and time starts incrementing up as well, it all moves towards crescendo where the whole thing just falls apart, even with the best case scenario for the conspirators.
Basically, if you want to have a conspiracy, you want as few people as possible.
Ideally one. It's much harder to uncover the whole thing. I mean, even there are conspiracies. What makes one viable and what makes one not viable? And it comes down to numbers and the amount of people involved in a big way. So if you really want to get away with something secretive, you need a very small number of people. I often get emails from very reasonable people who say, well, how do we know there's not a conspiracy? And if it helps a few people look at this and go, actually, yeah, you know what, on balance of evidence, you're right. With that number involved, at a minimum, it's unlikely there'll be a conspiracy. You'll never get the people that are dedicated ideologically to believing in a conspiracy no matter what. But you might get people in the middle ground. And that's important for things like climate change and vaccination, where we really need, a bulk of people to realize these are real things that we need to be aware of and to react to accordingly. Otherwise, we risk sleepwalking into some kind of dangerous inertia where we don't take the right evasive or preventative action.